All right, so this is the video for section 7.4 part day 1, and we're going to talk about how to add and subtract rational numbers. So if we just go back to the very basics, okay, so say we have 1/4 plus 1/4, okay. Hopefully you guys remember that when we have something like this, we get 2/4, which just simplifies then to 1/2. Okay, now the one thing I want to note is when we have like denominators, we add the top and we keep the bottom. Okay, but let's say I have 1/4 plus 1/2. Okay, if I have unlike denominators, we have to change these to like denominators. So we would change 1/2 to 2/4. And then we would add them and it would give us 3/4. And once again, we only add the numerator, we keep the denominators. Okay, so we're going to use that same concept when we add and subtract more difficult rational functions. All right, so let's look at example 1. These are two very simple questions because they already have like denominators. Okay, so when they already have like denominators, remember, we're just going to add the top, so 7 plus 3 is 10, and keep the bottom. Okay, now we do need to simplify as much as possible, so 10 over 4 goes to 5/2, so you could just do 5 over 2x. There's our final answer. Okay, don't forget when you do this, you have to say that x cannot equal to 0 as well. All right. So if we go to part B, guys, same thing, we already have like denominators, so we would go ahead, this time we're subtracting, not adding, so we just subtract the top, so 2x minus 5 over x plus 6. Okay, this doesn't simplify anymore. X is not equal to -6. This would be my final answer. All right, I encourage you to do this monitoring progress really quickly, so go ahead and pause this video, work these out, and then I'll show you the answers so you can check yourselves. All right, so this is what you guys should have gotten. Okay, now one thing I want to note is that over here on number 2, there's no real value of x, that x squared plus 1 would equal to 0. Okay, those would be imaginary numbers that would make that, and therefore we don't have to restrict the domain. All right, so those were some easy examples, but we are going to get a little more complex when we have unlike denominators. Okay, so remember, in order to add and subtract two rational functions, they have to have the same denominator. So before we can find the same denominator, we need to find the least common multiple, because what we'll find is the least common multiple is the same as the least common denominator. Okay, so on example 2, part A, it says find the least common multiple of 4x squared and 6x squared minus 24 plus 24. Okay, so we are going to go ahead and factor these just like we've done in the past. We want to factor them completely. So I'm going to take them separated and factor them completely. So this would factor to 4x squared minus 4. And then x squared minus 4 is a difference of squares, so this is just 4x minus 2 and x plus 2. Okay, now over here I could pull the 6 out and get x squared minus 4x. This is 24 plus 4. And then I would have x minus 2. X minus 2. Okay, so these both are fully factored. All right, so what I want to do is, remember when we're trying to find the least common multiple, we can't drop anything. We have to account for every single thing in both of these. Okay, so I want to look at 4 and I want to look at 6. Okay, and I want to say, what is the least common multiple of 4 and 6? Well, they both go into 12. 12 would be the least common multiple of 4 and 6. Okay, well then I have an x minus 2. Okay, and you can think of this as 6 parentheses x minus 2 squared because there's both of them. Now remember, we have to account for everything. Okay, so if I have 1 x minus 2 on the left and I have 2 x minus 2 is on the right, I have to take the higher of the two, so x minus 2 squared. I have to take both of these. Okay, so that accounts for the x minus 2, the x minus 2, the x minus 2. The only thing that has not been accounted for here is this x plus 2. Notice there's not an x plus 2 over here, but it doesn't matter. We have to account for everything, so I'm going to go ahead and put in here x plus 2, okay? So this here would be my least common multiple. All right, let's do another one. If you guys want to try to do this one on your own, go ahead and pause it and work it out, and we'll go over it. But I'm going to go over it with you guys. So I'm going to take the two things that I want to find the least common multiple of. Okay, so I have 6x squared minus 54, and then I have 9x squared minus 54x plus 81. Okay, and I'm going to factor completely both of them. So 6x squared minus 9. And then I have a difference of squares, so 6x minus 3, x plus 3. Okay, and then over here, I can pull out a 9, x squared minus 6x plus 9, and this is just 9, x minus 3, x minus 3. Or if I wanted to take it down to x minus 3 squared, I can do that as well. Okay, so now that both of them are factored, I want to look at this. So 6 and 9, I want to find the least common multiple of 6 and 9. Okay, so the least common multiple of 6 and 9 would be 18. Okay, I have an x minus 3 over here, and I have an x minus 3 squared over here. And remember, I have to take the bigger of the two, so I'm going to keep the x minus 3 squared. Okay, and last but not least, I have this x plus 3 here that I need to account for. I don't have an x plus 3 on the right side, but it doesn't matter. I still have to account for it. So this is x plus 3. Here's my least common multiple of the two. All right, so now I'm going to use those least common multiples, okay, and I'm going to use them to find like denominators, okay? So I want to find the sum of these, but notice they don't have like denominators. Okay, so I'm going to find the least common multiple of 9x squared and 3x squared plus 3x. So 9x squared and then 3x squared plus 3x. And just like I did before, I'm going to go ahead and find the least common multiple. Okay, well 9x squared doesn't cancel out anymore. 3x squared, I can pull a 3x out, and I'm left with x plus 1. Okay, so 9 and 3. Okay, I want my least common multiple. Well, 3 times 3 is 9, so my least common multiple is 9. Okay, I have an x squared and an x. Okay, I want to take the bigger of the two, so I want my x squared. This doesn't have anything else, but notice this still has an x plus 1. We have to account for that, so x plus 1. Okay, this is my least common multiple. Okay, but my least common multiple is also going to be my least common denominator. Okay, so I'm going to change the denominator of both fractions to this right here. Okay, so I'm going to look at it. So I have 7 over 9x squared. Okay, so I'm going to compare the denominator of what I have, the 9x squared, to this one here. Okay, so notice I'm missing the x plus 1. Okay, so I'm going to multiply this by x plus 1 over x plus 1. Remember, I can multiply anything by 1, and x plus 1 over x plus 1 is 1. Okay, plus, now I'm going to look at this. This is x over, and I'm going to go ahead and change this 3x squared plus 3x to 3x x plus 1. Okay, so I'm going to ask myself, what do I need to multiply this denominator by to get this whole thing? Okay, well, I have my x plus 1, and I have 3x rather than a 9x squared. Okay, so I'm going to multiply this, top and bottom, by 3x. Okay, so when I do that, remember we're multiplying, so we multiply straight across, so I'm left with 7x plus 1 over 9x squared, x plus 1, plus x times 3x is 3x squared, over 3x times 3x is 9x squared times x plus 1. Okay, now this turned out very nicely because now I have these same denominators, and so I can just add straight across. So I'm going to go ahead and distribute this. So 7x plus 7 plus 3x squared over 9x squared parentheses x plus 1. Okay, if I rewrite this a little bit nicer, this is 3x squared plus 7x plus 7 over 9x squared parentheses x plus 1. Okay, well, I want to see if I can simplify this any, but this cannot be factored. And because the numerator cannot be factored, this is as simplified as it gets. But I still do need to put restrictions on my domain. Okay, so I want to go back through the problem, and anywhere in the problem, if it makes the denominator a 0, I would have to restrict that from the domain. Okay, so right here, x cannot equal to 0. This is 0, okay, but when I factored it, right here, x cannot equal to -1. Okay, and those are my only two restrictions. So my overall final answer is this. All right, so let's do another one. If you're feeling adventurous and want to try this on your own, go ahead and pause this, work it out, and then we'll go over it. So I'm going to find the least common multiple of both of these. So on the left, I have a 12x squared. That cannot be simplified anymore. And on the right, I have an x squared plus x, which can be simplified to x times x plus 1. Okay, so my least common multiple, or my lowest common denominator, is, well, I have a 12x squared. Well, first of all, I just have a 12. I don't have a number over here, so 12. I have an x squared and an x. I want to take my bigger of the two, so x squared. And then because I have to account for everything, I'm just going to have an x plus 1. Okay, so I'm going to change my denominator of both to 12x squared, x plus 1. So 8 over 12x squared. Okay, I'm going to multiply it by, now if I compare these, I'm missing my x plus 1. So I'm going to multiply this by x plus 1 over x plus 1. Okay, and that's going to add to x over x squared plus x. Okay, and here I'm missing, actually, I'm going to put my factored form in here. X plus 1. There we go. That makes it a lot easier. And so here I'm just missing a 12x. So I'm going to multiply by 12x over 12x. Okay, when I do that, guys, I would get 8 times x plus 1 over 12x squared, x plus 1, plus x times 12x is 12x squared over 12x squared, x plus 1. Okay, now this is magical because notice I now have these same denominators among the two. So I can go ahead and multiply straight across. Okay, I'm going to go ahead and distribute this as I do that. So 8x plus 8. So 8x plus 8 plus the 12x squared over the 12x squared parentheses x plus 1. Okay, I'm going to rewrite this into nicer form. So 12x squared plus 8x plus 8 over 12x squared x plus 1. Okay, now here we do have a GCF in the numerator, right? They're all even, and they're also all divisible by 4, so I'm going to pull out a 4, and I'm left with 3x squared plus 2x plus 2 over 12x squared parentheses x plus 1. Okay, and now I notice that 4 over 12 can reduce to 1 over 3, so 1 over 3. So I'm left with 3x squared plus 2x plus 2 on top over, my 12 becomes a 3x squared parentheses x plus 1. And once again, I have to restrict my domain. So my x can't be 0 here. Can't be 0 here neither, but that's already covered. Or it can't be -1 here. And that is it. Okay, so this right here would be my final answer.